Hello, my name is David Levy. You are listening to the Observer's Notebook podcast. Enjoy.
Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 198 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I am Tim Robertson, the host of the Observer's Notebook, and also the coordinator of the training program within the ALPO. Hey, thanks for downloading and listening. The ALPO collects and analyzes observations of various solar system bodies and associated phenomena, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers, also known as the Strolling Astronomer. This podcast depends upon donations from you, our listeners, to keep it alive. If you enjoy what you hear in the Observer's Notebook, you can donate to it via Patreon by giving as little as $1 a month. If you feel even more generous, for $5, we receive early access to the podcast before it goes public. For a monthly donation of $10, receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can help us out by going to www.patreon.com/observersnotebook. And if you'd like to join the ALPO, membership begins at only $22 a year. Find out more at www.alpo-astronomy.org, or you can find the ALPO on Facebook. Just search for ALPO Astronomy. And this podcast also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear in the podcast, please subscribe. That way you'll never miss another episode. And now we're talking comets. And that means we have Carl Hergenrother. Enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And we're very excited to have today our comet expert, Carl Hergenrother, back on the podcast. Welcome back, Carl.
Thanks for having me yet again, Tim.
Yeah, now we're going to talk about the new comet of the century, right?
Oh, yeah. Mm-hmm.
Okay. So
at least it'll be the comet of October.
It'll be the comet, hopefully October, yeah. So we are recording this in mid-September. This podcast is going to be released October 1st. So if you want to talk to us about what the comet is, where it's coming from, and what we expect it to look like in the future.
Okay, so yeah, the comet of the moment is a long period comet called C-2023-A3 Tsuchinshan-ATLAS. And this was a comet that was discovered back in early January 2023 at the Purple Mountain Observatory, which is located outside of Nanjing in China, just inland from the central coast of China. Anglicized, we call it the Purple Mountain Observatory, but in Chinese, it's Tsuchinshan.
Oh, okay.
And this observatory has actually discovered a few comets going back to the early 60s. In fact, you remember not too long ago, a couple months ago, about a year ago, there was a short period comet called 62P Tsuchinshan, which got up to about 9th magnitude. So they have discovered about 5 comets or so.
Okay.
But the thing is, after they made their discovery in early January 2023, that was on a single night. And nobody else was able to find the comet or follow up on the comet. So it was just considered lost. And then towards the end of February, and they had discovered it with a 1-meter Schmidt telescope. And then towards the end of February, the ATLAS program. And ATLAS is a NASA-funded program, and ATLAS is actually an acronym, and it stands for Asteroid Terrestrial Impact Last Alert System. And this is a program that has telescopes spread all around the world, half-meter Schmidt telescopes in Hawaii, Chile, and South Africa. And it was their South African telescope that actually rediscovered or independently discovered the comet on February 22nd at 18th magnitude.
Mm-hmm.
Back then, the comet was 7 AU from the sun. 7 AU is kind of roughly the distance between Jupiter and Saturn's orbit.
Now, that was last year, right?
That was last year. Yeah,
Okay.
that was early 2023. And observations were found as far back as April 2022 back when the comet was 22nd magnitude.
Wow.
And at that time, the comet was 10 AU from the sun.
Wow.
So that's a similar distance to the distance Saturn is from the sun. So all during 2023, the comet steadily brightened from around, 18th, 19th magnitude. And then when we lost it as it went into solar conjunction around September 2023, it had already reached about 15th magnitude. When it came out of solar conjunction, this is late December 2023, it was about 13th, 14th magnitude. And it seemed to continue to brighten until the middle of April, when it hit about 10th magnitude. And then the brightening stopped. In fact, the brightening even looked like it kind of went into reverse. And the comet seemed to fade through the second half of April, through May, even into June, maybe early July, before the brightening started up again. And that got a lot of people scared because, comets, they don't always brighten kind of in a straight line, in a linear fashion. And sometimes, as we all know, there are comets that break up. They disintegrate. Most famously, Comet Ison, about 11, 12 years ago.
Right.
And Ison also showed this kind of brightening quirk of where it was brightening at a nice rate. And then for a couple of months, it started fading. Not just fading, apparently, as in it looked like it was getting fainter to those on Earth. It was fading in an absolute sense. That once you corrected for the distance from the sun and the distance from the Earth, it was actually it almost looked like the gas production rate was going down, and the comet was becoming intrinsically fainter. So there are a lot of people who look at these kind of stalls or fadings when the comet's brightening and then it stalls its brightness for a few months or even fades as a sign that this is a comet that is not going to survive perihelion.
Okay.
And that led to even a few papers coming out. And these are kind of quickly written papers that haven't gone through peer review yet because it really isn't time. And just saying, the comet is on the verge of disintegration or even is disintegrating. Though, to be honest, other than the comet looking like it was fading a little bit, the comet looked healthy in visual observations and CCD images. But there were a few dissenters out there and that said, well, maybe what we're looking at is something that we usually don't really address when we plot up the light curve of a comet. And that is comets have phase effects. So when you look at a comet, you can see it at different what they call phase angles. The phase angle is the sun-comet observer angle.
Okay.
And think of the moon. So when the moon is close to 0 degrees phase angle, it's at opposition. That's full moon. The comet's really bright. As we all know, the full moon is even, substantially brighter at full moon versus a day or two before or after. And that's because the phase angle goes to 0 and you get a lot of backscattering. The light is scattered directly back at you from the lunar surface. And that's kind of an enhancement that makes the surface of the moon brighter than it otherwise would be.
Yeah, comets don't generate their own light. They're reflected sunlight, just like the moon, just like the planets.
Exactly.
Yeah.
Exactly. And then if you go with the quarter phase or half moon, that's, 90 degrees phase angle, new moon would be 180. Well, for comets, you're not really seeing the nucleus, the hard, solid piece in the middle, this small asteroid-sized body in the middle. When you see a comet, really what you're seeing is the coma. You're seeing dust and gas, and especially the dust. And dust reflects light differently than, say, the surface of a giant body like the moon or even an asteroid. When you get to high phase angles, and this is when you're kind of looking at the comet when it's more in line with the sun, so you're kind of looking towards the sun, you can get a major enhancement of brightness as well.
Okay.
But kind of going back, the thing that happened in April was in mid-April, the comet seemed to fade. Well, mid-April corresponded with the comet going through opposition. So that corresponded with a time when the comet was around a few degrees of phase angle. So it was close to 0. And then it faded after that. So it's very possible and probably likely that the fading we saw from the comet wasn't due to it just, producing less dust. But just this, as the phase angle started increasing after opposition, it was scattering less light towards us.
Okay.
So it really was almost an optical effect.
Now, is that something that... I know every time a comet comes around, there are all these algorithms that get plugged in for predicting the magnitude. Is that something that we've ever really looked at before, or is that new?
We have looked at it before, but a lot of times it's simplified.
Okay.
So, like, again, a lot of times you don't take into account these phase angle effects.
Yeah, that's
They
what I'm wondering.
really only come into play when the comet is kind of close to being between the Earth and the Sun. And we'll talk a lot more about that later because the comet is also going to be in that geometry.
Right.
Or it's kind of going through opposition. And a lot of times you just ignore it because the phase angle does change, but maybe it's only affecting the brightness of the comet by a few tenths of a magnitude. And within the scatter observations, that's almost negligible.
Okay.
But every once in a while, you do get a comet that goes kind of straight through opposition, and it appears to stall in brightness, but it's really due to this phase effect. And in fact, Hale-Bopp did this when it was inbound. And for a while, people were going, oh no, Hale-Bopp's not brightening anymore. It's not going to be the comet of the decade, the century, whatever. And as it turned out, that was also just that phase angle effect.
Right. Okay.
So the nice thing is, so when you just look at it without taking into account the phase angle, it looks like the comet was brightening steadily from discovery through mid-April 2024, and then stopped brightening or even faded until about July, and then started brightening again. When you actually correct the observations for the phase angle effect, what you find is the comet steadily brightened from discovery to some points around December, January, this last December and January, when the comet was in conjunction with the sun and we didn't see it. And now it's brightening at a slower rate, but still brightening.
Okay.
So that fading we saw wasn't really real. It was just due to this phase.
Okay. Effect. That makes complete sense. I never thought about that before. Yeah.
Right. So that does bring up the point of, will this comet even survive perihelion? As we know, comets do break up.
Mm-hmm.
And some comets, even if they don't break up, have a habit of saying, disappointing us. Think Kohoutek, think Austin.
Mm-hmm.
And in the extreme case of a breakup, think ISON, or even Comet Atlas 2019 Y4 from a couple of years ago. We don't know if this comet is dynamically new or dynamically old. What I mean by that is a dynamically new long period comet is making its first close approach to the sun. This was like all long period comets, they were formed in the outer solar system. As the planets moved around during the early years of the solar system, long period comets were thrown out into the Oort cloud. And some comets were kicked in and have made multiple passes through the inner solar system. Those are dynamically old long period comets. But then we get ones that are making their first pass through and dynamically new. And a lot of these dynamically new comets, because they still contain a lot of really volatile ices that haven't been sublimated off the body, because they're making this is their first time getting heated since their formation. They look abnormally bright when they're discovered far out. And then as they get closer, they kind of don't live up to that initial brightness that you saw out there when you extrapolate, again, what you were saying, when you discovered a comet and you would say, oh, it's going to brighten at this kind of average rate. And these comets have a habit of not brightening at those average rates. Right. They brighten at a much lower rate. And so they don't appear as bright when they're close to the sun. Kohoutek was a perfect example. Mm-hmm. It was a comet that was really bright at discovery, really far out. And if you assumed a 10 log R, and that's R is in astronomical units, the distance between the sun and the comet. And the Earth is at 1 AU, which is 93 million miles or 150 million kilometers. But when you find a comet's out at 510 AU, and then you extrapolate, assuming a 10 log R rule to perihelion, you can get like Kohoutek, where you go, oh, it's going to be negative 10th magnitude, comet is and then it brightened, quote unquote, only at 7 log R, which is now that we know is a more typical brightening rate for long period comets, especially dynamically new ones. It gets up to -3. And the difference between -3 and -10, when you're only 5, 10 degrees from the sun, is huge. That's the difference between not being able to see the comet and it's a naked eye object. Just, block the sun out with your hand and there's a comet sitting there. And so when this comet was discovered, everyone assumed, okay, 8 log R, and that actually kind of has worked for the most part. But a lot of comets do disintegrate. And for this one, it looks like it's dynamically new, which means it looks like it's making its first close approach to the sun. But honestly, within the error bars, it can go either way. So we can't say too much.
What's the period of this comet?
That's the problem is we don't, it's pretty close to parabolic.
Oh, okay.
Right now, what they do for trying to figure out the period of the comet is, right now it's passing through the inner solar system. So the gravity of all the planets are tugging on it and it's changed its orbit. So you can't necessarily just pick the eccentricity that the comet currently has and figure out what its period is. What they do is they integrate the comet's orbit out to a distance of 200 AU before it came through the solar system to figure out what was its original period. So that's before all the gravity of the planets affected. And then looking forward, they'll integrate it out to 200 AU on the outbound leg and go, okay, this is what its period going forward will be.
Got it.
But for the most part, it's slightly hyperbolic, probably close to parabolic. And again, within the error bars, because we don't know, the comets themselves will push themselves around because, the dust we're seeing, the coma and tail we're seeing is all from material that's been ejected off the surface, almost like in giant geysers. When you're talking about a body that might only be a kilometer across, those geysers are they're forces pushing on the nucleus.
Little jets, yeah.
They're little jets, exactly. And they call them jets. So we don't know exactly what that activity was for the last 5 years.
Okay.
So we don't really know exactly whether this is a dynamically new or dynamically old.
Got it.
But even though dynamically new comets are more likely to disintegrate, we've seen dynamically old comets disintegrate too. It's just less likely.
Okay.
But there was a paper published by John Bortle, and everyone maybe remember John Bortle from his Comet Digest article that was in Sky and Telescope all through the late 70s into the 80s, and also a major contributor to the ALPO Comets section in its early days.
Yep.
And he was the first one to kind of make a correlation between the survivability of comets and their brightness, saying that fainter comets that come close to the sun have a habit of not surviving. And that was based solely just on really visual data. And then 2 years ago, David Jewett published a paper in the Astronomical Journal where he kind of did the same analysis, but used more physical data, where he was looking at the size of the comet nuclei based on their water production rates, and found that predominantly smaller nuclei that get closer to the sun are more likely to disintegrate. And he did suggest that while there's multiple mechanisms that can explain why a comet disintegrates, the most likely mechanism is rotational disruption. Basically, the nucleus is small and it's spinning, and these jets, if they happen to work in the right direction, will start spinning up the nucleus to the point where centrifugal forces at the equator are greater than the gravity of the object, and it just falls apart and completely disintegrates. Now, the thing is, we don't know anything about the size of the nucleus of this comet, but this whole lead up is just a caveat that we don't know if this comet will survive perihelion or even survive to get to perihelion. So everything I talk about here on with predictions of its brightness and its appearance and when it's observable will all assume that it's going to survive perihelion.
Yeah, perihelion, by the way, is the closest approach to the sun. So
it is, it's the closest approach to the sun. And for this particular comet, perihelion is on September 27th at a pretty small 0.039 astronomical units.
Oh, my.
So 0.039 is, you're talking distance of Mercury.
Yeah.
So it's going to get baked and it's going to get hot. So right now, the comet, we were observing it in the Northern Hemisphere. We lost sight of it in July. Southern Hemisphere observers lost sight of it in August, just because it was too close to the sun. There is a NASA sun-watching spacecraft called Stereo. There used to be two of them. One, unfortunately, broke. But Stereo A is still out there working. It's at 1 AU from the sun, kind of same orbit as the Earth, but it's not exactly where the Earth is. It's slowly drifting away from the Earth, so it's got a different vantage point than us here on Earth. And during most of August, it actually was able to see the comet as it passed through its main wide field of view. And we were able to watch the comet brighten from about 7th magnitude to 5th magnitude. Even though the comet is still, spatially close to the sun from our vantage point. Right now, being mid-September, it's at an elongation of only 16 degrees, so it's pretty close. It has been observed by observers in the southern hemisphere. It's been not only imaged, but even visually observed. And the magnitude estimates that have been sent in suggest that it's somewhere between magnitude 4.5 to 5.5, which is pretty good because that's kind of where the light curve that we produced based on all of the pre-August observations, it seems to be fitting that trend line there.
Yeah, and that's jumping within the range of naked eye.
Right. Though being only 16 degrees from the sun, it's in very, very bright twilight.
Right.
So it's still not naked eye yet. But hopefully it will get there. So right now in September, and of course this video will be released in October, hopefully by the time this video is released, we will have watched the comet get a little easier to observe in the southern hemisphere, and we'll probably start to see some observations come in from the northern hemisphere, still in bright, bright twilight. But the comet should, by say October 1st, when this video will be released, be around magnitude 2.
Okay. In the evening sky?
Actually, at this point, it's still in the morning sky.
Okay.
So right now it's in the morning sky, and by October 1st, it will still be in the morning sky.
Okay.
And at this point in time, the comet really isn't observable against a dark sky, unfortunately. It's still, like, for example, on October 1st, from the southern hemisphere, it's 5 degrees up at the start of nautical twilight. So it's still a pretty bright sky. And in the northern hemisphere on October 1st, it's only 2 degrees up at the start of nautical twilight.
So we're not going to see anything. So
magnitude 2, naked eye, probably not. Imaging, if you got a clear horizon, you probably can pick it out. I'm pretty sure you could observe it. And I'm sure people with binoculars and small telescopes might be able to see it as well. But unfortunately, the comet is moving back closer and closer to the sun during this period. So the first week of August, even though the comet is rapidly brightening, it's going to be deep in twilight, very close to the sun. Now, the nice thing is, again, we've got other vantage points to observe the comet at. And that Stereo A spacecraft that I mentioned that was able to observe the comet in August will pick up the comet again on October 4th through October 9th, when it should be close to a 0th magnitude object, even close to a negative magnitude object. Though Stereo will not be experiencing the comet as bright as we will. And the reason for that, if you go back to my discussion about phase angle effects, I said when, objects, whether it's the comet or the moon, is kind of at opposition at 0 degrees phase angle, there's this brightness enhancement due to backscattering. Well, dust experiences something called forward scattering of light. When you get to very high phase angles, which means you're looking at the object kind of in line almost with the sun, you get an extremely large enhancement in brightness. Now, for those of us old enough to remember overhead projectors, or the projector doesn't even need to be overhead. If the projector were just sitting on the table, there were certain angles where you would always see dust floating through the light beam.
Right. And
there were certain angles where you would see more dust than not. If you were standing behind the projector looking in the direction of the light, you saw some dust. If you were at a 90-degree angle, you didn't see much dust. But if you were kind of looking back at the projector, so, say you were the one giving the talk, you were standing in front of what's being projected, you're looking back at the projector, you see a whole bunch of dust going through the light beam. And same if there was a beam of light, say, coming through, a window or something, you would see the same thing, at your house. That is forward scattering, making that dust extremely, extremely bright.
Yeah.
It's that forward scattering that, honestly, in a lot of cases, is the secret sauce that makes great comets. For every Hale-Bopp, which was an intrinsically large monster comet that was bright no matter where we saw it in the solar system when it was at perihelion, whether we were close to it or it was on the far side of the sun, most comets that pass kind of between the Earth and the sun have this enhancement of a few magnitudes of extra brightness. It's actually what makes Comet Halley such a great comet. Because Halley has an orbit that runs in the opposite direction of the Earth, that's kind of in the same plane as the Earth's orbit. So you almost always catch Comet Halley passing between the Earth and the Sun. I don't mean exactly between the Earth and the Sun, but within 10, 20 degrees of the Sun, but between us. And so you get an extra 1, 2 magnitudes of brightness enhancement that probably push Halley from being there's a comet there to, ooh, that's a great comet.
Okay.
And that's been the case for almost every single appearance of Halley for the last 2,000 years, except, of course, for the one we all saw in 1986. Which didn't experience that enhancement. So this comet, Tsuchinshan-ATLAS, will have the same thing. And so this is a comet that should only peak at about magnitude 2. But after perihelion, it's going to pass within 3 degrees of the Sun. And because it's about 0.5 degrees from the Sun and 0.5 degrees from the Earth, it's actually between us and the Sun. This comet could experience several magnitudes of increased brightness to the point where at that time, and it's October 9th when it's doing this, it could be negative 4th magnitude.
Oh, my.
Now, that's great. Negative 4th magnitude is the brightness of Venus. But there's a caveat here. At that time, the comet is 3 degrees from the Sun.
Oh.
Right. So you're not seeing it against the dark sky. You're seeing it during daytime. And whether or not, and remember, the comet is also diffuse. It's got an extent to it. It's not a point source like the planets are, at least to your eye. Small telescopes. And so this will not be a brilliant object. It will not be an obvious naked eye object. It will not be an obvious daytime object during the daytime at this point. Okay. Not an obvious daylight object. But those people who have the equipment who can image close to the Sun will probably see quite a spectacular show. Now, the nice thing is after this, the comet starts to quickly race away from the Sun into the evening sky. So October 9th, we have it's in line with the Earth and Sun. It's basically passing from the morning sky to the evening sky. By October 10th, it's 4 degrees from the Sun, still negative 3. By the 11th, it's 7 degrees from the Sun, though it's dropped to negative 2. By the 12th, it's 12 degrees from the Sun, negative 1. If you've got a clear horizon, you will still be able to see it. Maybe not naked eye, but you'll be able to see it through binoculars and a telescope. But very quickly, by the time we get to the 13th and the 14th, now you're talking about an object, first from the northern hemisphere, that is now observable even when the sky is reasonably dark.
Cool.
You start talking about possibility of a 0th magnitude object. Now, unfortunately, even when you can observe it against the dark sky, the moon is a problem. The moon will be bright. And we really don't lose the moon until October 19th, October 20th, when the comet's significantly fainter. So even once it gets away from the twilight sky, we still might not be able to visually pull in the whole extent of the comet's tail because the sky is going to be bright from the moon. Okay. But going back a little bit in ALPO Comets Section history, the Comets Section was created in the late 50s. And the reason why it was created was because in 1957, there were 2 nice 0th first magnitude comets. One was a surprise comet, Comet Mercash, which was not seen as it went through perihelion and popped out right after perihelion as this brilliant 0th magnitude object. The other one was Comet Hergenrother.
Right.
Hergenrother, even though there's no relationship between Hergenrother and Tsuchinshan-ATLAS, they actually their orbits and their geometries, as we see them from the Earth, are very, very similar.
And that was a spectacular comet.
That was a spectacular comet. And the thing that everyone remembers about Hergenrother is that when, again, it popped out in the evening sky, a few days after it became visible, it had this sharp, long antitail. In fact, the antitail was longer than the main tail.
Right.
This comet will do the same thing.
Oh, my goodness.
So in a way, we might actually kind of seeing history repeat itself. And that by October 14th, when the comet is now, 21 degrees from the Sun, which isn't bad. I mean, 21 degrees, you're talking about the kind of, where Mercury is. You can see Mercury when it's at, its greatest elongation.
It won't be completely dark, but
Won't be completely dark, but you're still talking about the possibility of a comet that's around first magnitude.
yeah,
But it will have a nice long antitail.
fantastic.
And the nice thing is this antitail points at the sun, so it gets closer and closer to the sun, which means the phase angle is better, which means it gets brighter. So it is very possible we're going to have a comet with two tails. One tail, which is a kind of a broader dust tail pointing away from the sun, and then a very narrow spike tail pointing close to the sun.
Okay.
And in the days before that, assuming, again, we're competing with a bright twilight sky, you might even see kind of a curved main tail and just a kind of one side of the comet will just have dust, basically. Because what's going on is as the comet's pinwheeling around the sun, the dust tail is lagging behind.
Mm-hmm.
It's almost like a lawn sprinkler. And as we see it coming racing out of the sun, you'll see stuff moving away, and then you'll kind of see that curved part going back along the orbit. And so this could be a quite spectacular comet. And it kind of be a reminder of what Aaron Rolland looked like back 1957.
That'd be fascinating.
Now, say that the comet disintegrates. Say it completely breaks up in the weeks before perihelion. We're already a week before perihelion. Say it breaks up at perihelion. Okay? So now the comet comes out, and there's not much left of it. It's just a remnant cloud. It will still have the antitail, because the dust particles that we see in that antitail are large particles that were released by the comet already. They were released weeks ago, maybe months ago. So it's possible we could have a comet that breaks up, a headless comet, and all we have remaining is an antitail.
That'd be kind of cool, too.
That would be kind of cool, too. Yeah.
God, I love comets.
Yep. So the thing, again, with a lot of these really bright comets, the reason why they get bright is to get close to the sun.
Mm-hmm.
And also it helps with the phase angle effects. But these are short-term effects. Comet doesn't stay close to the sun for long. It doesn't stay at very high phase angles for long. So like a lot of these objects, you hear about these great comets and, Hale-Bopp being the outlier that was observable for months or years. A lot of these comets are only, naked eye for days.
Yeah.
Maybe a week before they fade. And this comet will be no different.
Okay. So you think
So most people... Oh, go ahead.
After the 14th, it'll fade pretty quick?
It'll fade roughly about half magnitude a day.
Okay.
But that adds up.
Yeah.
So by the time we get to the moon leaving the sky, and now the object's 40 degrees from the sun, it's well observable in the northern hemisphere against the dark sky, the moon's out of the way, you're talking third magnitude.
But still.
And then fourth magnitude, and by the time we get to early November, it'll drop below naked eye brightness. And then we'll be able to follow it out. And by the end of the year, it'll probably be about 10th or 11th magnitude.
Okay. But it's all northern hemisphere.
Mostly northern hemisphere. The southern hemisphere will be able to see the comet.
Okay.
But it will be very low. It'll be against the bright sky. And maybe like the last 10 days or so of October into the first 10 days of November, the southern hemisphere will be able to see it against the dark sky. But it won't be very high off the horizon. You're talking, 4 or 5, maybe 10 degrees at most off the horizon.
Okay.
So this one actually is a little better from the northern hemisphere.
Fascinating. This is great. What's your conservative prediction for this thing?
That's a good question. This comet is it's thrown us enough curveballs. And of course, being an object that might be dynamically new, there's still a possibility it won't survive. I am cautiously optimistic that this will be a nice comet, that it will kind of be a replay of Aaron Rolland. I think for most people, first, second magnitude comet, on October 14th, 15th, 16th is probably what you can expect, but hopefully it will be brighter than that. We'll just have to wait and see, which is why we like observing comets.
It's true. That's very good, Carl. Do we have any other comets coming in the near future besides this one?
There are a couple. I mean, we'll do our comets of 2025. Okay. 2025 is not going to be a very exciting year.
Okay.
just because there are not a lot of comets out there. There's almost no short period comets that are expected to be very bright. There are a few long period comets that come in and will get to very small perihelion distances, but they are probably more likely to break up than not.
Okay.
And they also are only observable from one hemisphere or the other. And at their brightest, they will also be even deeper in the twilight than A3 will be when it's coming out. So 2025, unless something new is discovered, may not be the most exciting comet year.
Okay. Sounds good. Carl, I want to thank you for coming on and giving us this discussion. It was really good. We both saw things this morning on the internet of photographs that were taken, I guess, this morning of the comet and little tail. So that was exciting to start this off with, too.
Yeah, that was Michael Mattiazzo down in Australia has been observing the comet the last couple of days, and he just visually observed it this last morning and estimated it was magnitude 4.6. And if that is true, then the comet is actually running brighter than the prediction. But we'll see as more observations come in.
Fantastic. All right, Carl. Well, I want to thank you for coming on the podcast today.
Thanks for having me, Tim.
All right. Well, that'll do it for this episode of the Observer's Notebook podcast. I again want to thank Carl Hergenrother for coming on and talking to us about Comet A3. This sounds exciting. Please get out there and observe it. And if you do, post your pictures on the ALPO website. Contact Carl. We have a nice gallery of comet images as well. Check out our brand new website and please submit observations on this comet. It's going to be amazing. We upload a new episode of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please rate us and review us. I really appreciate it. You can also listen to us on Apple Radio, iHeartRadio, Soundcloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and the podcast is also available now to it via Patreon. By giving as little as $35 a month, where you receive 1 year's membership to the podcast and producer credits on the podcast. I want to thank Steve Siedentop and Michael Moyer, the producers of this podcast, for their generous support. The link for Patreon as well as the link for the ALPO is in the show notes. You can get a hold of me at cometman@cometman.net or on Twitter at ObserversMDPod. And until next time, my hope is you always have clear and steady skies. Thanks for listening.